Getting humans to the moon is monumentally difficult. It's a feat that pushes the boundaries of engineering, science, and human endurance. Every step, from launch to landing, is fraught with risk and complexity. The Apollo program made it look routine, but that was only possible with immense national will and a budget that's unimaginable today. The world watched in awe as astronauts took those first steps, but behind the scenes, it was a race against time and technology. Now, as NASA's Artemis program aims to return astronauts to the lunar surface, old challenges have resurfaced, joined by new ones. The stakes are higher, and the expectations even greater, as we look to establish a sustainable human presence on the moon. Building and integrating new systems like the Space Launch System and Orion capsule has led to major delays and cost overruns. Each component must work flawlessly, and the margin for error is razor thin. The original 2024 Nalpor Lights and lines, these kangs minded didini toncher. Hopwise. Lines had slipped to at least 2026. Timelines keep shifting, and the pressure mounts with every delay. This slow, expensive approach has opened the door for new ideas. The private sector, with its agility and innovation, is eager to step in and offer solutions. Enter SpaceX, a company built on reusability, rapid iteration, and challenging aerospace norms. Their bold vision is reshaping what's possible in spaceflight. SpaceX has proposed a radical alternative for Artemis III, rethinking the mission architecture to potentially get NASA astronauts to the moon faster and more safely. The core problem, energy, remains the biggest hurdle to overcome. You need a lot to escape Earth, land on the moon, and return. Every kilogram of fuel counts, and efficiency is everything. NASA's plan uses single-use rockets and complex maneuvers. SpaceX's vision centers on in-space refueling. This could be a game-changer for deep space missions. By creating a petrol station in orbit, SpaceX could streamline the mission, offering NASA a choice: stick with the slow, government-led plan, or embrace a commercial alternative promising speed and simplicity. The decision could shape the future of lunar exploration. The stakes are high, and the world is watching NASA's next move. The outcome will determine not just who returns to the moon, but how humanity explores the cosmos for generations to come. So, what exactly is SpaceX's new plan for getting astronauts back to the moon, and how does it differ from previous approaches? The plan pairs two vehicles: SpaceX's reliable Dragon capsule, which has already flown multiple successful missions, and the massive next-generation Starship rocket, designed for deep space travel and heavy payloads. The mission begins not with astronauts, but with fuel. This crucial step sets the stage for everything that follows. Multiple Starship tanker rockets are launched to low Earth orbit, each one carrying a load of propellant to build up the necessary fuel reserves. These tankers dock with a Starship propellant depot in orbit, transferring their fuel before returning to Earth for reuse, making the process both efficient and sustainable. This sequence is repeated as many times as needed until the depot is fully stocked and ready for the next phase of the mission. Next, the uncrewed Starship Human Landing System, or HLS, launches, docks with the depot, and fills its tanks with the propellant needed for the journey to the moon. With the lunar lander fueled and waiting in orbit, astronauts launch separately aboard a Falcon 9 rocket, inside a Crew Dragon capsule, following a proven and safe launch profile. The Dragon capsule docks with the Starship HLS in orbit, and the crew transfers into the much larger Starship, preparing for their lunar adventure. The Starship HLS then undocks and heads directly to the moon. No need for a lunar gateway or complex orbital transfers, making the mission more straightforward. The very same ship that leaves Earth orbit is the one that lands on the moon, simplifying logistics and reducing risk. This approach consolidates what used to be many complicated steps into a single, streamlined mission profile. It leverages proven hardware, innovative engineering, and eliminates many of the risks and delays that have plagued traditional lunar missions in the past. The result is a simpler, more direct, and more reliable path to the lunar surface than ever before. SpaceX's plan is bold, ambitious, and could truly redefine how humanity returns to the moon for a new era of exploration. It's a mission built for speed, efficiency, and safety, paving the way for the next giant leap in space exploration. Side by side, the differences between NASA's and SpaceX's lunar mission plans are stark and reveal two very different philosophies for returning humans to the moon. NASA's approach is a complex symphony of new hardware: SLS, Orion, European Service Module, and Starship HLS, all needing to work perfectly together in a tightly choreographed sequence. Delays in any part can stall the entire mission, as we've already seen with previous Artemis launches and test flights. In contrast, SpaceX's plan relies almost entirely on its own hardware, giving the company more control over schedules, integration, and the ability to rapidly iterate and solve problems. The only outside element is the Falcon 9 crew launch, which is already highly reliable and has a proven track record of safely carrying astronauts to space. Most mission prep, like fueling the lander and final checkouts, can happen in advance, so the lander is ready and waiting in orbit, minimizing last-minute risks. For safety, SpaceX uses the proven Crew Dragon and Falcon 9 for launching humans, reducing risk and leveraging years of operational experience. NASA's plan, on the other hand, depends on the unproven SLS and Orion for crewed lunar flight, both of which are still in their early stages of operational history. SpaceX's direct-to-moon approach also eliminates risky lunar orbit dockings. All critical transfers happen in low Earth orbit, close to home, where rescue is more feasible. If something goes wrong, astronauts can quickly return to Earth, reducing exposure to danger and increasing mission flexibility. This makes the SpaceX plan arguably safer, more robust, and potentially more adaptable to future lunar missions. On paper, the Dragon Starship plan is simple. In reality, it's a massive engineering challenge. Filling a propellant depot may require 10 or more Starship tanker launches, demanding a rapid, reliable launch cadence SpaceX is still developing. Managing cryogenic propellants in space is another hurdle. The depot must prevent fuel boil-off for weeks or months, requiring advanced insulation and cooling. Docking 2 giant Starships in orbit is uncharted territory, demanding extreme precision and robust control systems. The most controversial step: transferring crew onto a fully fueled Starship, a wet dress transfer traditionally avoided due to risk. SpaceX must prove this is safe, providing extensive data to satisfy NASA's safety standards. Each step, launch, docking, fuel transfer, and crew transfer, must be flawless. The scale and complexity are unprecedented. SpaceX is betting it can master these challenges before NASA's own hardware is ready. If it succeeds, it will set a new standard for lunar missions. For SpaceX's lunar plan to become reality, Starship V3 must prove itself. First, it needs to reach orbit and return safely, a baseline requirement. Next, it must demonstrate in-space propellant transfer, 2 Starships docking and moving fuel between them. This is the linchpin of the entire mission and a top priority for NASA. Starship V3 must also show it can operate reliably for weeks or months in space, with zero boil-off storage and robust life support. A long-duration, uncrewed test flight will be needed to prove this. Finally, SpaceX must land an uncrewed Starship on the Moon, validating the full mission profile. Only after these milestones will NASA consider putting astronauts aboard. The burden of proof is high, but so is the potential reward. If SpaceX proves Starship V3's capabilities, the impact will be profound. NASA, under pressure to land on the Moon before the decade's end, would find SpaceX's offer hard to refuse. Success would make SpaceX the leader in lunar transport, giving it a near monopoly on Moon and exercise. This would also accelerate SpaceX's own ambitions, using lunar missions as a springboard for Mars. Every lunar landing would double as a test for future Mars missions, all funded by NASA. It would shift NASA's role from mission architect to collaborator, validating the commercial space model. For SpaceX, it's the ultimate checkmate, winning the lunar race and changing the rules for future exploration. The future of lunar access could be in SpaceX's hands. Returning to the Moon is harder than anyone expected. SpaceX's Dragon Starship plan is more than an alternative, it's a disruptive leap. It challenges the old model with reusability, speed, and commercial innovation. The hurdles are real orbital refueling, cryogenic storage, and complex, in-space operations. But if SpaceX succeeds, it could break the cycle of delays and make lunar landings routine. For NASA, it's a lifeline. For SpaceX, a crowning achievement. This could mark a turning point, ushering in a new era of commercial-led space exploration. The bet is bold, but if it pays off, it could accelerate humanity's journey beyond Earth.